Okay, hi guys. We're going to look at limits a little bit further today. The first thing we're going to do is look at something called the constant rule. It says the limit as x approaches c of a is equal to a. And we're going to look at that graphically in a minute. And the other one is the linear rule. The limit as x approaches c of x is c. So I think these rules will become a little clearer when we look at an example. So example 1, the limit as x approaches 3 of 5. Well, what does the graph, the function f of x equals 5 look like? Well, it's simply 1, 2, 3, 4, 5. It's simply a horizontal line through 5. So as x approaches 3, right here, as x is going towards 3 on the function, y is constantly staying 5. So as x approaches 3, y is approaching 5 from both sides. From the left, it's approaching 5, and from the right, the y is approaching 5, because the y is constantly 5. That's why it's called the constant rule. So the limit as x approaches 3 of 5 is 5. And that holds true for any x value. The limit as x approaches, say, negative 2 is still is 5. Now the linear rule is a little different. This is the function f of x equals x, which we know is our line that goes through 1, 1, 2, 2, 3, 3, so on and so forth. So as x is approaching 3, y, from this direction, y is approaching 3 from the left, and from the right, y is approaching 3. So it's 3, because it's the function f of x, or y, equals x. So x and y are equal to each other. So as x approaches 3, y is going to approach 3. So what would the limit as x approaches 5 of x be? Well, it would be 5, because it's going to go through the point 5, 5. Now let's look at what happens when we add or subtract two functions. So this refers to the limit of sums or differences. If you have the limit as x approaches c of some function f of x plus or minus some function g of x, you can look at their individual limits, the limit as x approaches c of f of x, and add it or subtract it to the limit as x approaches c of g of x. So this mainly applies to polynomial type functions. So example 2, if we look at the limit as x approaches 3 of the function x plus 4, that's equivalent to the limit as x approaches negative 3 of x plus the limit as x approaches negative 3 of 4. So these actually combine these two rules above. The limit as x approaches, that's a negative 3. You can't read it. The limit as x approaches negative 3 of x, well, we know that from the linear rule, is negative 3. And the limit as x approaches negative 3 of 4, that's the constant rule, that's 4. So you can just simply add those together, and the answer is 1. Now, take a look at this. Could I have simply plugged negative 3 into there? And you could. Negative 3 plus 4. The answer is 1. Oops, positive 1. Okay. So now the limit as x approaches 4 of 6 minus x, well, that would be equivalent to the limit as x approaches 4 of 6 minus the limit as x approaches 4 of x. Okay, and it's a minus because that's minus. So this is the constant rule. That's 6. This is the linear rule. The limit as x approaches 4 of x is 4. So the limit as x approaches 4 of this function is 2. And again, take a look at it. Could I have simply plugged 4 in for x? And the answer is yes. Okay. Let's look at now the product rule. What happens when we multiply two functions? What's the limit as x approaches c of f of x times g of x? Well, you simply look at their individual limits and multiply them. So if I'm looking at the limit, and this is a 2, the limit as x approaches 2 of 5x is the limit as x approaches 2 of 5 times the limit as x approaches 2 of x. And again, we've got the constant rule and the linear rule. Here is the constant rule. This is 5. Times the limit as x approaches 2 of x is 2. The answer is 10. And once again, could I have just plugged the 2 in? 5 times 2 is 10. So the answer is yes, you could have just plugged the 2 in for the x. Okay. Now limits of powers and roots. What if you had a function to a power? So this is saying the limit as x approaches c of f of x to the nth power. What you do is you look at the limit as x approaches c of f of x, and then when you find that limit, you raise it to the power. Same thing with the root. If you had the limit as x approaches c of the nth root of f of x, you simply look at the limit as x approaches c of f of x, find that limit, take the nth root. Okay, so the limit as x approaches 1 of 3x minus 5 is equivalent to the limit as x approaches 1 of 3x minus 5 all to the 4th power. So remember, what we were seeing with those polynomials is we can simply plug the 1 in. So this becomes 3 times 1 minus 5 becomes negative 2 to the 4th power, which is 16. Again, could I have just plugged 1 in? 3 times 1 minus 5 to the 4th power is also 16. Okay, so let's try this one. The limit as x approaches 0 of the square root of 5x plus 8. Could I plug the 0 in? Sure. The quick way is simply to plug the 0 in. You would get the square root of 5 times 0 squared plus 8. That's the square root of 8, which reduces to 2 root 2.